Hello and welcome friend. In this video we solve some examples. Example is on your screen. Show that integration of f of x between the limit 0 to 1 equal to 2 by 3 where the values of the function are given. F of x equal to 1 divided by 2 raised to n when 1 divided by 2 raised to n plus 1 less than x less than equal to 1 divided by 2 raised to n. So first let us see the value of the function. Okay, f of x equal to, this is 1 divided by, if we take 1 divide, this is equal to 0 when n is equal to 0, that is for 1 divided by 2 less than x less than equal to 1 we have taken, where n is equal to 0. Now let us take n is equal to 1. N is equal to 1, we have 1 divided by 2 square less than x less than equal to 1 divided by 2. N is equal to 1, we get f of 2. N is equal to 2, n is equal to 2, we get 1 divided by 2 square. And here for which value, which interval, 1 divided by 2 cube less than x less than equal to 1 divided by 2 square. N is equal to 3, n is equal to 1 divided by 2 raised to 3. This is for 1 divided by 2 raised to 4 less than x less than equal to 1 divided by 2 raised to 3. Likewise it is a 0 at x is equal to 0. Okay, so these are the values of the function. Now therefore we divide this range 0 to 1 of this function. Instead of 0 to 1 we take 1 divided by 2 raised to n, right? F of x into dx equal to here we write it as 1 divided by 2 to 1 f of x into dx plus 1 divided by 2 square to 1 by 2 f of x into dx plus 1 divided by 2 raised to 3 to 1 divided by 2 square f of x into dx plus 1 divided by 2 raised to n minus 1 to 2 raised to n to 2 raised to n plus 1 2 raised to n plus 1 f of x into dx, like this. Okay, no, this is a 2 raised to n minus 1 2 raised to n 2 raised to, whenever there is a 2 raised to n, here is 2 raised to n minus 1. Now see this 1 divided by 2 to 1 f of x 1 to 1 by 2 to 1, value of this function is 1, so this is 1 by 2 to 1 into dx plus 1 by 2 square to 1 by 2 integration here 1 by 2 square to 1 by 2 integration of 1 by 2 into dx plus in the next interval we have 1 divided by 2 raised to 3 to 1 divided by 2 raised to 2 1 by 2 square into dx plus 1 divided by 2 raised to n to 1 divided by 2 raised to n minus 1. Likewise here what will be the 1 divided by 2 raised to n less than x less than equal to 1 divided by 2 raised to n minus 1. This will be 1 divided by 2 raised to n minus 1. Okay, so this is 1 divided by 2 raised to n minus 1 into dx. Every value is a constant, so 1 into integration of x1, so this is 1 minus 1 by 2 plus 1 by 2 constant and integration 1 by 2 minus 1 by 2 square plus 1 by divided by 2 square 1 by 2 square minus 1 by 2 raised to 3 plus here 1 divided by 2 raised to n minus 1 divided by 2 raised to n minus 1 divided by 2 raised to n minus 1, or this is 1 by 2 plus 1 by 2 and here 1 by 2 minus 1 by 2 square, this is 1 divided by 2 square, plus 1 divided by 2 square, here 1 divided by 2 raised to 3, plus 1 divided by 2 raised to n minus 1, and we get here 1 divided by 2 raised to n minus 1. Okay, so here the 2 raised to n minus 1, 2 square, 2 square, 2 square, 2 raised to n, we get here 1 divided by 2 raised to n minus, we get here 2 raised to n, right. Now then let us put these values now to calculate. We can take 1 by 2 common. If we take 1 by 2 common, 1 by 2 into 1 plus 1 divided by 2 square, plus here we have taken 1 by 2 common. 1 by 2 common, we get 1 by 2 and 1 by 2 raised to 3. 1 by 2 and 1 divided by 2 raised to 3. 1 divided by 2 raised to 4, and we write it as 1 divided by 2 square whole square, plus. Similarly here we can write 1 divided by 2 raised to 2 square whole raised to n minus 1. Okay, 1 by 2, 1 n minus 1, right. So this is equal, now this is equal to 1 divided by 2 into 1 divided by 4 minus 1 divided by 4 into 1 minus 4, 1 divided by 4 raised to n. Then this is this 2 and this 4, we get 2, and this will be 2 divided by 4 minus 1, 3 into 1 minus 1 divided by 4 raised to n. Okay, integration of the f, right. What is this? This is of f of x into dx from 1 by 2 raised to n to 1 equal to 2 by 3 into 1 minus 1 divided by 4 raised to n. Now as n tends to infinity, we get here 0 to 1 f of x into dx equal to, this will be 0, this will be 0, and we get 2 divided by 3. So this is, now we prove another problem. Show that the function, this bracket x, square bracket x, where square bracket x denote the greatest integer not greater than x. That means if x is equal to suppose 5.2, then this function 5.2 will gives us 5, because the integer values are up to 5.2, integer value 0, 1, 2, 3, from minus also, okay, 4, 5 and 6. Then 6 is an integer but greater than 5.2. So we have to choose the greatest integer value up to this 5.2. So greatest integer value near, very close to this 5.2 is a 5, not greater than 5.2 is 5. Okay. Similarly, therefore, this integration 0 to 3, this bracket function x, greatest integer function, we call it as a greatest integer function, we divide this as 0 to 1 plus integration 1 to 2 and integration 2 to 3, right. Then you can see that if my x is 0.1, then minus 2, minus 3, 0, 1, these are the integer values very close to 0.1, and I have to choose the greatest value of integer. Greatest value of this integer, I cannot take 1 because it is greater than 0.1. Greatest value not greater than this 0.1 is 0. Similarly, if x is 1.2, then the greatest integer value not greater than 1.2 is 1, and here therefore this is equal to integration 0 to 1 0 into dx plus integration 1 to 2 1 into dx plus integration 2 to 3, the greatest value is a integer value is a 2. Here we get 0 and plus integration of x between the limit 1 to 2 plus 2 into integration 2 to 3 equal to here 2 minus 1 plus 2 into 3 minus 2 equal to 1 plus 2 equal to 3, and therefore the greatest